Welcome friends, I am Arivumani, working as Assistant Professor in Department of EEE, Government College of Engineering, Bargur. So in this video, we will see what is the basics of power factor and what are all the techniques and what are all the effects of power factor improvement. So before going to see what is meant by power factor, we should know the basics. I will not take much more time. We should know the difference between alternating current and direct current, AC and DC. From supply point of view, source point of view, if they delivers either voltage or current irrespective of time, that is a constant voltage and constant current, constant power, it is known as direct current, DC supply. In the alternating current, the voltage, current, power, all are the variable of time with respect to time, then it is called alternating current. DC current is a direct current, constant current, and alternating current is the variable current, variable voltage, variable current with respect to time. So in direct supply, the power is the product of voltage and current, V into I. Then it is called VI, but in alternating current, it is not equal to V into I. Why it happens? So in the circuit point of view, load circuits, in the circuits and load point of view, the DC circuit will gives only the form of resistance, that is from Ohm's law, V is proportional to I, then V is equal to IR. So resistance is the ratio between voltage and current. But in AC circuit, it consists of basically three elements: inductance, capacitance and resistance. So in inductance and capacitance, it is having the relationship of differential circuit and integral circuit. So if in inductor, the relation between voltage and current is V is equal to L di by dt. So the voltage signal and current signal has some time delay, time difference. Either in if you are using a inductor circuit or a capacitor circuit, you have the time difference between voltage signal and current signal. So it has some angle. The angle between voltage and current, it has some angle. Then the power is equal to VI cos pi instead of V into I. In DC circuit, the power is equal to VI, but in AC circuit, it is VI cos pi. That is, it means that the VI is called as apparent power, that is a complex power. The portion of power is act as a useful power. For example, if you take a motor, in motor, the power is, if you measure the power using a wattmeter, if you measure power, it is the real power. That is, the power is used as a mechanical energy or electric energy. That is called a active power or real power. This power is equal to VI. V is a RMS value of voltage, I is a RMS value of current, and cos pi is the cosine of power factor angle. So power factor angle is angle between voltage and current. So the reactive power, it means the power is converted into electromagnetic field, electromagnetic flux or electromagnetic field. So this reactive power is used to generate the magnetic energy. So the reactive power is related to the energy and active power is related to the energy per unit time. So in this triangle, you see the power. There are the three basic power. VI cos pi is the active power, VI sin phi is the reactive power, and VI is the apparent power. The phasor sum of active power and reactive power is called apparent power. So power factor, if you take a simple RLC circuit, the power factor is defined in three ways. First one, cosine of angle between V and I. and another one resistance by impedance. So the impedance involves the R plus jx. X is the reactance. The X has two components, inductive reactance and capacitive reactance. Inductive reactance is positive, capacitive reactance is negative. So if you take a complex number, the complex number has a real part and imaginary part. Imaginary part will be either positive or negative, but real part is always positive. So here the power across the resistance is always positive, but inductive power either it may be positive or negative. The cosine of the angle between V and I will be positive or negative. If I lacks voltage, that is voltage V and I angle, if you take a reference is voltage, so I passed after voltage signal passed means it is lagging. If I have the positive angle with the reference to voltage, it means the leading voltage. Lagging voltage, leading voltage. In inductive circuit it is lagging, in reactive circuit it is leading. And the original definition for power factor, because it is power factor, if you take a definition of cos pi, it may be a cos factor. R by Z, it may be a impedance factor, but original definition of power factor is active power to the apparent power. Active power divided by RMS value of voltage and RMS value of current. In another definition of active power is, some of you may be not knowing this, if you supply 230 voltage 5 ampere in a AC circuit, it generates the power. So this power will be equal to 250 watts. Assume 250 watts. The same power will be given in the DC supply. It generates the same heat loss, same copper loss. That is another one definition for active power. So in most of the circuit is operating unity power factor, because there are the three terms: active power, positive reactive power, negative reactive power. If positive reactive power is cancelled by negative reactive power, then there is no reactive power. The total power is absolutely equal to the active power. So R plus P plus JQL minus JQC. So JQL, JQC will be get cancelled. That is, inductive effect will be compensated by the capacitive effect. Reactive power is present, but positive reactive power is compensated by the negative reactive power. Then there is no net reactive power. Then the power factor, active power divided by apparent power, will be equal to the unity. But in practice it is not possible. So power factor will be lesser than the 1. That is called a low power factor. So there are some disadvantages of low power factor. That is, first one, large kVA rating of equipment. It means active power is equal, but if there is a low power factor, the kVA is the unit of apparent power. kW, kilowatts, is the unit of active power, and kVA suffixed by R, it is the unit for reactive power. Active power kilowatts, reactive power kVA. kVA is the apparent power. So we can write the relationship between kVA and kilowatts is that kVA, the kilowatts is equal to kVA into cos pi. So kVA is equal to kilowatts divided by cos pi. So if power factor is low, then kVA will be larger, because kVA rating is inversely proportional to cos pi. So it will be increased, that greater conductor size, because power factor is R by Z. So if impedance is resistance is lower, impedance will be larger. The impedance will be larger means the conductor size also larger, and copper loss is large, because low power, due to the low power factor, the suppose if you fix the kVA rating, kilowatts will be larger, so there is a large copper loss. And power voltage regulation. because of the inductive voltage across the inductor and capacitor causes the voltage regulation will be lesser value and reduce the handling capacity of the system. So these are all the disadvantages of low power factor. So we should operate any system with unity power factor. It meets some advantages. What are the causes of low power factor? Which creates the low power factor? In practical, we are using domestic loads. All are the resistive type, and sum of loads, that is induction motor, will be the best example for absorbing the reactive power. So if you there is another method for compensating the reactive power. If you use the induction motor, there are RL type of load. It takes inductive power. So due to the reactive power consumed by induction motor, it creates the low power factor. The another one, arc lamp, that is arc lamps, electrical discharge lamps and industrial heating furnaces operate at low lagging power factor. That is welding takes larger reactive power, then it creates the low power factor. If the load on the power system is varying, being high during morning and evening and low at other times, during low load period, supply voltage is increased, which increases the magnetizing current. This results in the decreasing power factor. So it is in the generator point of view, it creates the magnetizing current. So it also creates the low power factor. So the first method, if a positive reactive power is compensated by negative reactive power. We remember the Newton's law, every action has its own reaction. So if you connect a capacitor, it produces the negative reactive power which opposes the positive reactive power. Then the power factor will be improved, it equal to the unity. So if you use a static capacitor, it not varies with time. Static means constant, dynamic means it vary with respect to time. So first point, they have low losses. Second point, they have little maintenance as there are no rotating parts. So it can be installed easily. They can be easily installed as they are light and require no foundation. They can work under ordinary atmospheric conditions. So maintenance both are very less. That just if you use a capacitance, it will be enough to compensate the power. But some disadvantages there. That is first one, the life is ranging from 8 to 10 years. The second one, they are easily damaged if the voltage exceeds the rated value. That is the high voltage impulse, all are affecting the capacitor. It is physically damaged. So once the capacitor are damaged, their repair is uneconomical. That is we can't we should replace with another capacitor which is having the higher value. So it is the one time installment. So another component is synchronous condenser. If you operate a synchronous generator with leading power factor, it acts as a capacitor. Then it is called as a synchronous condenser. So it is otherwise known as dynamic capacitor. So the phase angle is given. It also acts as a synchronous condenser, synchronous capacitor. So a synchronous motor takes a leading current which when over excited, then therefore behaves as a capacitor. So simply it is tell us an over excited synchronous motor running on no load is known as synchronous condenser. So the advantages are, by varying the field excitation, the magnitude of current drawn by the motor can be changed by any amount. So the magnitude will be changeable. If you use a static capacitor, it is a fixed value, but here the capacitance value will be variable. The second advantage is the motor windings have high thermal stability to short circuit current. The faults can be removed easily because of the dynamics of synchronous motor. So in the dynamic magnitude, that is change of magnitude of current is possible, that is variable capacity is possible, and stability, thermal stability to short circuit current is also possible, which is not available in the capacitor. And if any fault occurs, it can be removed easily. And there are some disadvantages, because when compared to capacitor, in capacitor there is only reactive power loss, that is electrostatic losses. But in motor, there more losses are there, because the efficiency of motor is very less. There are dynamic losses, mechanical losses, magnetic losses are there in the motor. So maintenance cost is higher compared to capacitor, static capacitor, and it produces noises because it is a rotating component. And except in sizes above 500 kVA, the cost is greater than that of the static capacitor of the same rating, because it is an electrodynamic machine. And the one more disadvantage of synchronous condenser is, as the synchronous motor has no self-starting star, therefore auxiliary equipment has to be provided for this purpose. That is, electrostatic starting of synchronous motor is required. So, the use of synchronous condenser is very less compared to capacitor. And the third technique is phase advancer. The phase advancers are used to improve the power factor for induction motor. So in induction motor, the phase advancer, that is change of winding, is constructed inside the motor. We see the low power factor of an induction motor is due to the fact that it is stator winding cross exciting current which lags behind the supply voltage by 90 degrees. If the exciting ampere turns can be provided from some other AC source, then the stator winding will be relieved of the exciting current and the power factor of the motor can be improved. That is, addition of the damping will be provided inside the winding. So the advantages of phase advancer are: the exciting ampere turns are supplied at slip frequency, therefore lagging KVR drawn by the motor are considerably reduced. So slip frequency, we know the synchronous frequency, difference between the synchronous frequency and frequency of the rotor. The second one, the phase advancer can be conveniently used where the use of synchronous motor is unadmissible. It is another one advantage. The disadvantages of phase advancers is that they are not economical for motors below 200 HP. That is, power rating is low, then the phase advancer will not be used. Okay, thank you. If you have any doubts in this topic, you can comment under this video. I will explain later. Thank you.